Astrotometry log. It's June 16th, 2009. Bit of information for those of you who are doing cyclone CME correlations. Justin Shaw had asked about a recent CME and is predicting a hypersymmetric cyclone. I think that that's probably accurate judging from the appearance of the CME, but it's also possible that something will influence, something from the past or the future even, will influence that movement, that hypersymmetric movement, before the time-space hypersymmetry coalesces. I guess that's the way I'm looking at it now, is that into the now there is a sort of coalescence of the time-space causal chains that determine the now from the possible pasts and the possible futures. In other words, the amount of time that it appears to take something to travel from the sun to the earth is the disturbance in a particular subcarrier of the common carrier. And so while the common carrier is more an instantaneous sort of mechanism that deals with physical manifestation in the moment, there are these other harmonics of that conveyance through time-space, which is why we have the appearance of the celestial spheres. And so as we perceive this coronal mass ejection moving out from the primary time axis, there's a theoretical time in three-dimensional space that it would take those particles to travel to the Earth. As they do in the astrotometric understanding, they disturb that common carrier, but they also disturb one another. And so if there's one that comes in to that space, to the time space from the past, or if there's one that between the time it takes the CME's influence to arrive at the Earth also takes place. In other words, if there's something that takes place between the time that it would normally take the hypersymmetric activity to occur, if something happens in between that time, another coronal mass ejection, then something in the future of that event can change what will happen. And so there's, like I said before, the causal chains in astrotometry are not linear. There's multiple dimensions of causality in astrotometry. Also, if you're looking at a flat map like this one from the NRL, you might not notice the cyclones that happen on the edges. If you're looking at a flat map, it has edges that are cut. And so a cyclonic storm might be disguised in the edges or in the distortion of the flattening of the map. And so in this one from NRL, you'll see the upper right and upper left corners of the map do not indicate a cyclone. But if you look at a spherical map, you notice that there's clearly a cyclone in the northern hemisphere. And this isn't a tropical cyclone. This is just a cyclonic movement. This is just a cyclonic storm. It's not the type of cyclone that normally causes any type of disturbance on a continent, because it happens in a place where there's not any land masses. And so if you're using the flat maps, beware that you might not see the cyclone you're looking for if you're looking on the edges, especially the smaller ones from the smaller CMEs. And so as far as from this coronal mass ejection, I think that there is a pretty good chance, I would say probably 85% chance, that we will see in the next day or so the formation of a tropical cyclone, an actual tract named storm from this particular coronal mass ejection. There was a small coronal mass ejection that followed it, but I don't think that that ejection is going to prevent the formation of a tropical cyclone in the next couple days, maybe 4 days at the most.